see it, segment it, build it. A complete computer vision to 3D reconstruction pipeline powered by RoboFlow plus Aether OS. Why this pipeline exists? Manual 3D asset creation takes hours per object, we automate it in seconds. Existing CV tools don't connect detection to segmentation to 3D reconstruction. Aether OS agents need to see, understand, and act on visual data autonomously. Goal: photograph anything to detect it to segment it to reconstruct it in 3D. Architecture overview. Input layer, camera feeds, uploads, screenshots, any image source. Detection: RFDETR model trained on RoboFlow, identifies objects plus people. Segmentation: SAM2 instance segmentation, pixel-perfect masks per object. Quality gate, confidence scoring, blur detection, occlusion filtering. Routing: people to pose estimation path, objects to 3D reconstruction path. RFDETR, why not YOLO? RFDETR is a transformer-based detector, no anchor boxes, no NMS post-processing. Better at detecting overlapping objects in cluttered scenes. RoboFlow provides one-click training with automatic augmentation. Our model, 87.2% map at 50 on custom dataset after just 100 epochs. Inference at 45 FPS on RTX 4090 real-time capable. Training pipeline deep dive. Training images, 2,847. Augmented samples, 8,541. Map at 50, 87.2%. Training time, 47 minutes. Model size, 42 megabytes. Data collection strategy. RoboFlow Universe, pre-labeled datasets for common object categories. Custom captures, phone photos with varied lighting, angles, backgrounds. Synthetic data, Blender renders of 3D models with random HDRI environments. Active learning, model flags low confidence predictions for human review. Auto-labeling, SAM2 generates masks, RFDETR proposes bounding boxes. Annotation workflow. RoboFlow Annotate, browser-based labeling with Smart Polygon tool. Label Assist, model pre-annotates, human corrects, 4x faster than manual. Class hierarchy, person, vehicle, furniture, electronics, food, animal. Export formats, Coco JSON, YOL of 8, Pascal VOC, all generated automatically. Version control, every dataset change is tracked and reproducible. Segmentation with SAM2. Segment anything Model 2, zero-shot instant segmentation from Meta. Takes RFDETR bounding boxes as prompts, no additional training needed. Generates pixel-perfect masks even for complex shapes like hair or foliage. Multi-mask output, picks the highest IOU mask automatically. Runs on device via ONNX runtime, 200 milliseconds per image on GPU. Quality gate system. Minute confidence, 0.75. Minute mask area, 5000 px. Max blur score, 100. Minute resolution, 256 by 256. The quality gate in detail. Confidence filter, rejects detections below 0.75, reduces false positives. Mask area filter, ignores tiny fragments that can't reconstruct well. Blur detection, Laplacian variants, blurry crops produce bad 3D models. Occlusion check, if mask touches image border, flag as partially visible. All thresholds configurable per class via Aether OS capabilities.yaml. People path, pose estimation. Detected humans route to media pipe pose estimation pipeline. 33 key points extracted: head, shoulders, elbows, wrists, hips, knees, ankles. Pose data feeds into SMPLX body model for rigged mesh generation. Output, animated GLB with skeleton, ready for Unreal Engine or Blender. Future, real-time motion capture from webcam feed. Object path, 3D reconstruction. Segmented objects route to multi-view reconstruction pipeline. Single image, Hunyuan 3D generates mesh from one photo in 30 seconds. Multiview, Colmap plus NERF for photogrammetric reconstruction from 20 plus images. Output formats, GLB, PLY, OBJ with UV-mapped textures. Mesh cleanup, automatic decimation, hole filling, normal recalculation. Inference server architecture. AetherOS integration points. MCP tool, detect_objects runs RFDETR on any image, returns JSON detections. MCP tool, segment_image runs SAM2, returns base64 masks plus metadata. MCP tool, reconstruct_3D triggers Hunyuan 3D pipeline, returns GLB path. Agent skill, visual_analysis chains detect to segment to quality gate to root. Chronicle logging, every inference logged with latency, confidence, model version. MCP tool registration. Real-time monitoring dashboard. Aetherveil dashboard, live inference metrics, model performance graphs. RoboFlow dashboard, dataset health, annotation progress, training curves. Pulse integration, GPU utilization, memory pressure, inference latency P95. Chronicle alerts, model drift detection when confidence distribution shifts. Auto retraining trigger, when map drops below threshold on validation set. Performance benchmarks. Detection latency, 22 milliseconds. Segmentation, 198 milliseconds. 3D reckon, single 28s. End-to-end, ~31s. Throughput, 45 fps. Failure modes and recovery. Low confidence, object requeued for multi-angle capture automatically. Segmentation bleed, morphological erosion shrinks mask by 2px to clean edges. 3D artifacts, mesh validation rejects non-manifold geometry, retries with higher resolution. GPU OOM, batch size auto-reduces, large images tiled and stitched. Network timeout, retry with exponential backoff, fall back to CPU inference. What we learned. Data quality model complexity, cleaning 200 bad labels improved map by 8%. SAM2 zero-shot is shockingly good, skip training a custom segmentation model. Quality gates save downstream compute, reject bad inputs early. Version everything, dataset, model weights, inference config, thresholds. Build the pipeline modular, swap any component without rewriting the rest. Roadmap, what's next? Video stream processing, real-time detection plus tracking across frames. Multi-GPU inference, distribute across AetherOS compute pool. Edge deployment, ONNX export for mobile and embedded devices. Federated learning, train across distributed datasets without sharing raw images. Agent autonomy, Aether agents trigger the full pipeline based on natural language. See it. Segment it. Build it. From pixels to 3D assets, fully automated, agent orchestrated.